Hey, this is Math 6, Unit 5, Lesson 11. Dividing numbers that result in decimals, which means that it's going to keep on going a little past the number we start with. Okay, so we're going to find some quotients that are not whole numbers. So first off, we have a number talk, evaluating quotients. So evaluate the quotients mentally. So if I think about 400 divided by 8, I can recognize that. I know 8 times 5 is 40. So I'd say this is about 50 right there. At 80 divided by 8, well, 8 goes in 8 about one time, so with a 0 there, we make that a 10. 16 divided by 8 is 2, that's no problem there. And now I have 496. Okay, now that one might get you a little stuck there, but think about this. We have 400, then we have an 80, and we have a 16. When I add these up, that combines together to make 496. Which means if I divide all those by 8, I'm going to have 5062. Right about like that is the idea, and that's how you want to start looking at it. Okay, so it's just idea here is that there's ways to take numbers that you don't really know how to divide and to evaluate them with some mental math by breaking them apart into numbers that you do know. You take that 496 and you break that into a 400, which is easy to work with. Then you're left with a 96. You say, I'm not sure about that one, so you break it up into an 80 and you break it up into a 16. And so now you're able to work with that. If you don't want the 16, you break it up into a 10 and you break it up into a 6, right? You can keep on going until you get numbers that you want to work with, that you want to be able, that you can play with, okay? That's the idea. Okay, keep on dividing is optional activity number 2, which you may or may not have done in class. That's okay. So it says, here's how May used base 10 diagrams to calculate 62 divided by 5. She started by representing 62. We have 1, 2, 3, 4, 5, 6, 10 blocks and 2 ones. She then made 5 groups, each with 1 10, and there was 1 10 left. She unbundled it into 10 ones and distributed the ones across the 5 groups. So on the next page here we have her diagram. This is for 62 divided by 5. Alright, let's take a look at what she did. Again, this is 62 divided by 5. So she had her block, her tens block, she used 5 of them there, and then she took her remaining 10 block and she unbundled it and turned it into 1, 2, 3, 4, 5, 6, 7, 8, and then we had 2 more ones. And then with these 2 ones, she had to figure out something to do with them, so she unbundled them and unbundle them into what she called tenths. So there'd be 10 and 10, so 20 tenths, and we count them up. We have 1, 2, 3, 4 times 1, 2, 3, 4, 5. So that became 20 tenths right there. So discuss these questions with a partner and write down your answer. May should have a total of 12 ones, but a diagram shows only 10 ones. You can see there's only 10 ones there. Why is that? So why does she only have 10 ones when she should have these extra 2? And what we mentioned here was, well, she's only showing how she divided it evenly. So she had to convert or unbundle. She unbundled 2 ones to make 20 tenths. So she took these extra 2 ones and she unbundled them to make 20 tenths. That way she could share them evenly. She did not originally have tenths, but in a diagram, each group has 4 tenths. Why? Why? Well, those came from the 20 tenths that she created when she unbundled, right? The 2 ones. That's how she got those there. So what value has May found is the next question in 62 divided by 5. What value is this? So if we look across at what one person has here, what does one person end up actually having? They have 1 10, they have 2 ones, then they have 4 tenths. Because they're tenths, they actually put a decimal point right there. So the value that everybody actually gets when you do 62 divided by 5 is 12.4. This is our tens, our ones, our decimal, and then our tenths place there. Okay, so that's how that works. Let's look at another one. Okay, the next one here is finding a quotient again by drawing a base 10 diagram or by using partial quotient method. Okay, we'll do both just to kind of have some practice here. It's again a little tricky with the space, but we can do it. So we do 511 divided by 5. So doing partial quotients, first of all, we say, okay, how many groups of 100, or how many groups of 5 are in 500? Well, we would say that there are 100 groups of 5 inside of 500. 100 times 5 is 500, and so it leaves us with 11 left over. Okay, so how many groups of 5 are in 11? Well, we would say in our case there are 2. Now this is where you gotta be careful, because I have to put it in the right place value, right? 2, not over in the tens place, but in the ones place. Okay, 2 times 5 is 10, so we subtract and we still have 1 left over. I don't want a leftover spot, so I'm going to go ahead and add a decimal and a decimal and a decimal, okay, and extend my line a little bit here, and then I'm going to add a 0. I can keep adding zeros here for as many as I need, okay. I'll put 2 there just to start with. I'll bring down the 0, okay, and now I'm saying, okay, how many 5s are in 10? Now again, I know there are 2, and actually what I'm asking is how many 5s are in 10 tenths, okay, and we'd say 2 still, so 2 times 5 is 10, and we subtract and we have 0. Now at that point, because I have a 0, I can then add up my columns, right, to see what my quotient will be, and my quotient is going to be a 1 and a 0 and a 2 and a decimal and a 2, so we have 102.2. Okay, and that's what we have there. If I want to use the diagram way, I'm doing 511 divided by 5. Let's make 5 groups here. So we have group 1, group 2, group 3, group 4, and group 5. First of all, everybody, I have 511, which means I have 500 blocks. So everybody gets one of those. That's nice, right? But then I have only 1 tens blocks. I have one of those. I can't show that nicely, can I? So I'm going to convert this 1 tens block into 10 ones. So let's do 10 ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now we've shared nicely those 10 ones, there. But I still have one more 1 left. Well, this one here, what am I going to do with that one? Okay, I can't share it one person, so I'm going to convert it into, or unbundle it into tenths. And they drew those little hash lines, right? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is our decimal point here, right? That's where our decimal goes. And we notice here we have 100, we have no tens, we have 2 ones, and we have 2 tens. So doing with a diagram, you end up with the same thing. Again, the diagram takes a little longer, and you have to make sure you have your pictures right. And it's nice because it's only divided by 5. If we were dividing by 16, we wouldn't want to draw 16 pictures. Okay? Let's take a look at number 3. It says 4 students share $271 prize from a science competition. How much does each student get if the prize is shared equally? So we're going to take our 271 and we're going to divide that by 4 people is the idea. Alright, so again, in this case here, how many groups of 4 are in 20 or 2? We would say none. Or we can say how many groups of 4 are in 200. Let's do it that way. Let's do the partial. We'll do partial quotients. How many groups of 4 are in 200? Well, there are going to be about 60 groups of 4. You can start there. Okay, and so 60 groups of 4 is going to be 60 times 4 is 240. We subtract this out, we have 31. So how many groups of 4 are in 31? That's going to be about 7. 7 times 4 is 28. So we subtract, we have 3 left over, so I don't have a 0 yet, right? That means I need to add a tenth here. Put a 0 right there. So how many 4s are going to be in 30? Again, we would still say 7. There's going to be a 0.7 here, including our decimal up there. For 28, and we subtract. And then we have a 30 minus 28 is 2. So add another 0, bring it down. And how many 4s are in 20? We would say there are 5. But this 5 goes, watch your place value, goes here at 0.05 for 20. And now we have finally a 0. So now when I combine what I have here in all these place values, we have a 6, we have a 7, we have a decimal, we have a 7, and we have a 5. So when 4 students divide that much money, they each get $67.75, just like that one there. Okay, let's look at activity number 3, which is called using long division to calculate quotients. Alright, so here's how Lynn calculated 62 divided by 5, okay, when she did this one. So she set up the numbers like so, 62 divided by 5. She subtracted 5 times 1 from the 6, so 5 times 1, which is here, leaves you the 1. And then she wrote the 2 down from the 62, brought that down, and so then she did 5 times 2 is 10, okay, and so she subtracted that there. We can see she has a decimal here, and that's her little magic line for the decimal is going to go, and she included a 0. And then she decided that there were 4 groups of 5, inside 20, and she got the 20 there, but that's where the decimal is going to be. So Lynn put a 0 after the remainder of 2. Why? So why did she put this 0 right there? Why does this 0 not change the value of the quotient? Well, she puts a 0 there because she doesn't want to have a remainder. She wants to make sure that she can give everybody an equal part with nothing left over. This 0 comes from recognizing that I'm going to use a tenth, and I'm going to carry this out a little further in order to figure that out. Lynn subtracted 5 groups of 4 from 20. What does the 4 in the quotient represent? So this is, what does this 4 represent? This is 5 groups of 4 tenths. That's what it actually represents there. 5 groups of 4 tenths. Okay, which is going to be shown here, which is actually 2.0. So for her answer, what value did she find? She found to be 12.4 right there. Let's do some practice of these here. It says use long division to find the value of each expression, then pause so your teacher can review your work. Or in your case, do it and then see if you got what I got, right? So the first one, we have 126 divided by 8. How many groups of 8 are in 1? 0. How many groups of 8 are in 12? 1. 1 times 8 is 8. Subtract. 12 minus 8 is 4. We bring down the 6. How many groups of 8 are in 46? Well, 8 times 5 is 40, so that gets me pretty close there. We subtract and have 6, and we notice, oh, gonna have to keep going, so let's add our decimal, and I always add my decimal to my quotient right away so I don't forget that on accident. Bring down our 0. How many groups of 8 are in 60? We would say 7, because 8 times 7 is 56. When we subtract that there, we have 4. We add another 0 to the 100th place there. And how many groups of 8 are in 40? We would say 5. 8 times 5 is 40, and our remainder is 0, so we'll stop right there. On the next one, we have 90 divided by 12. And this one here, we might recognize that 7 times 12 is going to be 84. We've done that before. And that leaves me with 6 left over. I don't want a remainder, so I'll put a decimal and a tenth, and I'll add my decimal above to my quotient so I don't forget about it. Bring my 0 down, so now I have 60. How many groups of 12 are in 60? We would say that there are 5. 5 times 12 is 60, and no remainder, and so we just stop right there. Okay? Alright, let's take a look at number 3. 3 has some more for us to practice with. It says use long division to show that 5 divided by 4, or 5 over 4, 5 fourths, is 1.25. Well, let's show that's true. So here is 5 divided by 4. Okay? Alright, so 4 goes into 5 one time. 1 times 4 is 4. We subtract and we have 0. Oh, sorry. We subtract and we have 1. We have 1. I put a decimal here, put the 0 that I meant before there, bring that down. Put my decimal point up right away. 4 goes into 10 about 2 times. 2 times 4 is 8. We have 2 left over. We're going to add another 0. And 4 goes into 25 times. And now we have 0, no remainder, so indeed 5 divided by 4 is 1.25. Okay, and we'll do that same thing for the rest of these here. So this is 1 divided by 8. I'm going to go ahead and put a decimal and a 0 and a 0 and a 0 just to have some spaces to hold for me. 8 goes into 1 0 times, so put my decimal up right away, just right above it. 8 goes into 10 one time. 1 times 10 is 8. We subtract. 10 minus 8 is 2. Bring down the 0. 8 goes into 20 2 times because 2 times 8 is 16. 20 minus 16 is 4. Bring down another 0. And there are 5 groups of 8 inside of 40. And we have 0 left over, and that matches there. In part B, we have 4 divided by 5. So that's going to be 4 divided by 5. And again, I can add a couple placeholders here. Add a decimal place there. 5 goes into 4 0 times. There are 0 groups of 5 inside of 4. But there are 8 groups of 5 inside of 40. When I subtract, I have 0, and I stop right there. And finally, 1 divided by 25, a 0.00. 25, there are 0 groups of 25 in 1 decimal point. There are 0 groups of 25 inside of 10, but there are 4 groups of 25 inside of 100. So we could say this and have 0 left over. Okay, so it's an interesting way for you to kind of verify that these division problems work out to be those decimal places there. Okay, and that's it. So let's look at number 4. Noah said we cannot use long division to calculate 10 divided by 3 because there will always be a remainder. What do you think Noah meant by there will always be a remainder? So let's take a look at what he's saying. 10 divided by 3. If we were to do this here, what would happen? We would have 10 divided by 3. What's he talking about? How many groups of 3 are in 1? 0. How many groups of 3 are in 10? We would say 3. So that becomes 3 times 3 is 9, and we subtract, we have 1. Okay, so far okay. Decimal, let's bring down a 0 here, and now 3 goes into 10. Still 3 times, right? 3 times 3 is 9. We subtract, and we have a remainder of 1. Do you see a pattern here? Every time I multiply by 3, I get 9, and when I subtract, I have a remainder of 1 again and again, and it never does end. So what he's saying there will always be a remainder is that 10 cannot be divided by 3 evenly to the place where it would ever stop. Okay, there's always going to be 1 left over. So do we agree with this statement? Yes, we agree, because we can show here that this is going to continue forever and ever and ever and never going to stop. Okay, so and if we wouldn't do that one, we would stop there. Okay, and so in math world, sometimes what we do is we'll write this out as 3.3 and we'll put this little bar over the top to say this is going to repeat forever and ever and ever. Okay, so if you ever see that, that's what that means. I don't think we see it in our book here, but just as something to give you. To summarize today, dividing a whole number by another whole number does not always produce a whole number quotient. So when we look at something like 86 divided by 4, we can think of dividing 86 into 4 equal groups. Okay, and those are our 4 groups. So easy to go 10, 20, 30, 40, 50, 60, 70, 80. The 10s work no problem. But the ones, we have 1, 2, 3, 4, we had 2 left over, right? So you have to take those 2 and unbundle them into tenths. And in doing that, that gives you 20 tenths. Okay? And they break those up to say, well, what am I going to do with those 20 tenths? Everybody needs one. So 20 tenths divided by 4 groups gives everybody 5 tenths. And there they are right there. So everyone would end up having 21.5 or 21.5. So we can see the base 10 diagrams how that works out there. We can also then recognize that we can calculate it using long division by continuing to run this out to the right, kind of adding that decimal and 0 and bringing it down until you get to the place where you don't have any remainders left, and then you could actually stop right there. Okay, so that's what we talked about today. Let's work on your homework. We'll come back and check it together in just a few minutes. All right, homework time, Unit 5, Lesson 11. Use long division to show that the fraction and the decimal in each pair are equal. Okay, so we're going to do 3 divided by 4. The way I remember how to do this here is I think about wrestling. I used to coach that a long time ago. And the person on the top is going to be the winner, and they get to live inside the house because they pinned their opponent. This guy lost. So when I make my house, okay, the 3 gets to live inside of it because he won the wrestling match. This is 3 divided by 4, just like that. Because he's on top, he gets to live in the house. So 4 goes into 3, it doesn't, 0 times. We'll put a decimal there. So we're going to add a 0. 4 goes into 30, 7 times. 7 times 4 is 28. We subtract and we have 2 left over. Add another 0, bring it down. 4 goes into 20 5 times, and 5 times 4 is 20 with no remainders. And that does match our value there. The next one, the 3 won the wrestling match, gets to live inside of our nice house, so 3 divided by 50. Okay, 50, we're going to put a decimal here. 50, how many groups of 50 are in 3? 0. We put a 0 there. Okay, how many groups of 50 are in 30? Still 0. And how many groups of 50 are in 300? We would say 6. 6 times 50 is 300. The remainder is 0. And our last one here. Won the wrestling match, lives in the house. 7 divided by 25. How many groups of 25 are in 7? 0. So let's add a 0 there. How many groups of 25 are in 70? Well, it's going to be 2. Because 2 times 25 is 50. We subtract, and we have now what's left. We have 20, which is less than 25, so we're good there. I got to bring down a 0 there. And 25 times 8 actually does equal 200. So no remainder, and we have 0.28, which matches there. And we show that the fractions are equal to the decimals. Number 2, May walked 1/8 of a 30-mile walking trail. How many miles did May walk? So she did 1/8 of 30 miles. Okay, we could think of it a couple ways. We could think of this as being 1/8 of, generally means we're going to multiply 30. And when you multiply that out, you have 30 divided by 8. Okay, so 30 gets to live in the house because it's on top. 8's on the outside. How many groups of 8 are in 30? We would say 3, which is 24. 30 minus 24 is 6. We don't have a whole number yet, or a 0, so let's bring this down. 8 goes into 60. Well, that's going to be 7, which is 56. We subtract and have a 4. Still don't have a, we have remainders, so let's keep on going. And we have a 40 now. 8 goes into 40 5 times. 5 times 4, 8 is 40 with nothing left over. So how far did she walk? She went 3.75 miles if she did 1/8 of 30. And you could check that out by multiplying this by 8, and you should get 30. Okay? If you ever want to check your work, that's how you do it. Number 3, let's use long division to find each quotient. Write your answer as a decimal, which tells us we're going to have some decimal work here, correct? So 99 divided by 12 looks like this. 99 divided by 12. Since I have some decimal work, I'm just going to add some zeros to start with. Doesn't hurt to add more to the right. Doesn't do anything wrong or good. It's just what it is. 12 and 99. I'm going to go with about 8. Let's see what that does. 8 times 12 is going to be 96. Okay, so that's pretty good. Subtract, I'm left with 3 left over. Decimal point up here. And bring down the 0. How many 12s are in 30? That's going to be 2, because 2 times 12 is 24. 30 minus 24 is 6. Bring down the 0 to make 60. And how many 12s are in 60? We would say 5. With none left over. 8.25. Next one, 216 divided by 5. That's 216 divided by 5, like that. How many 5s are in 2? 0. How many 5s are in 20? 4. 4 times 5 is 20. We subtract. We have 1 left over. Bring down the 6. How many 5s are in 16? There are 3. 5 times 3 is 15. We subtract and have a 1. Because we have a decimal, we have a remainder, we're going to keep on going a little bit. So bring down a 0, add our decimal there to start with. So decimal, 0 down. 5 goes into 10. How many times? 2. Are there 2 groups of 5 inside of there? We have 0 left over, so you have 43.2. And finally, 1,988 divided by 8. How many groups of 8 are in 0 or in 1? 0. How about 19? We'd say 2. 2 times 8 is 16. We subtract. We have a 3. Bring down our 8. We have 38. How many 8s are in 38? We would say, well, almost 5. 5 times 8 is 40. So let's go with 4. 8 times 4 is 32. Subtract, and we have 6. Bring down that 8. How many 8s are in 68? Well, for sure 8, because 8 times 8 is 64. We still have a remainder of 4 right there, so we'll have to keep going. At this point, we'll put a decimal here and a decimal there and add a tenth. And we'll bring that 0 down and make a 40 once again. And how many 8s are in 40? We would say 5. 5 times 8 is 40, with no remainders there. And our answer is 248.5, just like that one. Okay, let's move on. Next page, number 4. To find the decimal of 9/25, Tyler reasoned that 9/25 is equivalent to 18/50, which is, let's see, 9 times 2 is 18, 25 times 2 is 50, and to 36 over 100. Well, 50 times 2 is 100, 18 times 2 is 36. So the decimal equivalent of 9/25 is 0.36, or 36 hundredths. Use long division to show that Tyler is correct, because he is. So let's prove this here. So 9 is on top, gets to live in our house. 9 divided by 25. Let's go ahead and put our decimal point there. Let's add some space holder zeros and see what we get. So 25 is, there are 0 groups of 25 in 9. There are 3 groups of 25 in 90. So 3 times 25 is 75. When I subtract, I have 150 or 15 left over. I bring down the 0 for 150. And there are 6 groups of 25 in 150. And that's all we have there. So is the decimal of 18/50 also 0.36? Use long division to support your answer. So is this decimal also going to be the same thing? Well, the answer is going to be yes, but they want us to prove it anyways, okay? Because all we're doing is multiplying both by 2. So let's go ahead and prove this one. So here's 18, lives in the house because he's on top. And 50 is there. Put a decimal point and a 0 and a 0. Alright, how many 50s are in 1? 0. 50s in 18, 0. 50s in 130. I got 50, 100, 150. So we're going to say 3. 150. I subtract, and I have 3 left over there, 0. Bring that down. And if 3 times 50 was 150, and 300 is double that, doubling 3 is 6. 6 times 50 is 300. And sure enough, you still end up with 0.36. Alright. And number 5. So 5 minus something equals 4.329. Okay, so this 5 is, there's no squares there, so it's just simply 5. So I can put some zeros here, and we can work our way, in a sense, backwards. 9 plus what gets you to 0? It gets you to 10. We would say 9 plus 1 is 10. So it's a 0 there. The 10 gets carried over here. So 1 plus 2 is 3, plus 7 is 10. So there's the 0 and the 1 for the 10. 1 plus 3 is 4, plus 6 makes 10. So 0 is there, we carry the 1, and 1 plus 4 plus nothing gives you 5. Okay, so it's still kind of working backwards there. And you could check it out by putting zeros and dividing and see what you come up with. Okay, let's try that for this one here. Okay, so if we were going to do this here, we would say we have to borrow 9. Oh, sorry, it becomes a 0. This becomes 10, we borrow, becomes a 9, and then we're going to have to put this a 10, borrow becomes a 9, and a 10 there. So 10 minus what gives you 5? You would say 5. 9 minus what gets you to 1? Let's say 8. 9 minus 9 gets you to 0, and then 0 minus 0 gets you there. Okay, and you get the same thing here as well. Okay, we want to say here we're going to borrow, that becomes a 10, a 9, 10, a 9, a 10. 10 minus 7 is 3, 9 minus 3 is 6, 9 minus 1 is 8, and 0 minus 0 is 0. So that's what we have there. And our last one here for today. Use the equation 124 times 15 is 1860, and what you know about fractions, decimals, and place value to explain how to place the decimal point when you compute 1.24 times 0.15. Okay, So the difference between 124 times 15 and this and that is the place values, right? Is where the decimals are going to be at. So we know that this one here is going to be equal to these digits 1860, but where's the decimal going to go? The difference between this one and this one is the decimal has been moved to the left 1, 2, 2 spots there, and here also 1, 2 spots there. Okay, or we'd go this way technically 1, 2, 1, 2. So we're going to move this decimal 1, 2, 3, 4 to show that it's going to be equivalent. If we wanted to think of it this way, we could work it out like so. 124 times 0.15. This is like multiplying by 100, multiply by 100 in order to get to 124 times 15. Multiplying by 100 moves it this way, 2 spaces. Now 124 times 15, we already knew was 1860. But now I'd have to divide that by 1, 2, 3, 4. 1, 2, 3, 4 by 10,000. Okay? So when I do 1860 divided by 10,000, that's going to be moving the decimal 1, 2, 3, 4 to the left. So 1860, 1, 2, 3, 4 to the left, puts it right there like so. Okay? That's it for today's lesson. Hope you have a great day, and we'll see you next time.